This is Shuttle Launch Control. Joining us now in Firing Room 4 at our Public Affairs Console is our Space Shuttle Launch Director, Mike Leinbach. And Mike, I think we're looking at you to kind of explain how this problem evolved, what it is that you are seeing, and maybe give us some idea what the go-forward plan is and how much time are we going to need to turn around.
Okay, I'll be glad to do that. And can you hear me okay? I wasn't hearing you all that well, but well, let's see. The issue is with one of our auxiliary power units, which provides the power to the hydraulic system for the orbiter. And the exact problem was a thermostat on one of the fuel lines for that auxiliary power unit, and we need to keep those lines warm to prevent them from freezing on orbit. So we have two thermostats, two heaters for each fuel line for each APU. And on auxiliary power unit number one of those two heater units failed, and the troubleshooting we did on it proved that it was a hard failure. We were not able to get it to come to life no matter what we did. We tried to let the line cool down just by normal means and to see if the thermostat on that heater would kick in. That did not happen. We tried to command the heater from the cockpit of the orbiter. That did not happen either. So we know we have a hard failure in that heater string for that one auxiliary power unit. There was another heater upstream of that is also exhibiting some funny behavior. So what we believe we have now is a problem in one of our LCAs, a load control assembly. It's essentially a switch box that says we probably have a failure, a short, actually in that box or in one of the electrical lines to that box or from that box. We're not quite sure yet. We won't know until we get into the aft of the orbiter and do some detailed troubleshooting. But the issue is that we didn't want to commit to flight with only one of two heaters on those auxiliary power unit fuel line because of the chance that if you lost that one good one on orbit, then you run the very high risk of freezing the fuel in that line, and therefore the auxiliary power unit would not function, and therefore you wouldn't have full hydraulic power, which is a case you never want to get into for re-entry without hydraulic power coming from one of the three auxiliary power units. So the course of action today is to scrub. We're in the process of draining the external tank right now. That'll take another hour or so. We'll set up to gain entry into the aft compartment of the orbiter overnight tonight, and probably tomorrow afternoon we'll get into the aft, start putting in our platform set to get to this load control assembly, which is down inside the aft quite a ways, and so it's going to take us a bit of time to get in and do that. And then once we're in the avionics bay where that LCA exists, we'll be able to do our troubleshooting and see if we need to change out that box or whether we find a short in the line, that type of thing. So right now, it obviously a scrub turnaround scenario of a minimum of 72 hours right now. We've declared a minimum of 72. And I'm going to have a scrub turnaround meeting with my launch team at 2:30 today where we will refine that plan based on engineering's input to see what level of troubleshooting they want to do to see if it extends that 72 hours even longer than that. But today the orbiter is not ready to fly. And as we always say in this business, we will not fly before we're ready. And so that's the case we're in today.
So right now we're no less than 72 hours, but till you get through the troubleshooting the aft, you really can't tell how much more time we would need.
That's exactly right. We're absolute minimum 3-day scrub turnaround now.
All right, Mike. Well, thank you very much. And that will conclude our launch commentary at this time. This is Shuttle Launch Control.